Generate random numbers with a given, numerical, distribution. I have a file with some probabilities for different values, for example. I would like to generate random numbers using this distribution. Does an existing module that handles this exist? It's fairly simple to code on your own. Build the cumulative density function, generate a random value, 0, 1, and pick the corresponding value, but it seems like this should be a common problem and probably someone has created a function/module for it. I need this because I want to generate a list of birthdays, which do not follow any distribution in the standard random module.
scipy.stats.rv_discrete might be what you want. You can supply your probabilities via the values parameter. You can then use the RVS method of the distribution object to generate random numbers. As pointed out by Eugene Pacomuth in the comments, you can also pass a p keyword parameter to numpy.random.choice, for example. If you are using Python 3.6 or above, you can use random.choices from the standard library. See the answer by Mark Dickinson.
Since Python 3.6, there's a solution for this in Python's standard library, namely random.choices. Example usage. Let's set up a population and weights matching those in the ops question. Now choices population, weights, generates a single sample, contained in a list of length 1. The optional keyword only argument k allows one to request more than one sample at once. This is valuable because there's some preparatory work that random.choices has to do every time it's called, prior to generating any samples. By generating many samples at once, we only have to do that preparatory work once. Here we generate 1,000,000 samples, and use collections.counter to check that the distribution we get roughly matches the weights we gave. An advantage to generating the list using CDF is that you can use binary search. While you need ON time and space for preprocessing, you can get k numbers in OKLogN. Since normal Python lists are inefficient, you can use array module. If you insist on constant space, you can do the following: ON time, O1 space.
Okay, I know you are asking for shrinkwrap, but maybe those homegrown solutions just weren't succinct enough for your liking. Smile? I pseudo-confirm that this works by eyeballing the output of this expression. Maybe it is kind of late. But you can use numpy.random.choice, passing the p parameter.
If you want to support the channel, please consider subscribing.